Okay, so I've had some questions about this table, this task I've asked you to do. It's one we would have done in class, so it's maybe not the most clear what you have to do. So I'm going to go ahead and kind of start to do it, but not actually do the calculations, and let you guys do the calculations. So let me just go ahead and put numbers in here. I don't really need to use my whiteboard. I can't draw very well on the screen, but it doesn't really matter. So a lot of you have been asking me, what do you put in for force, right? Is that just your weight? And then if I scroll down to the to the second one, where we have to start thinking about power as well, that's where the time comes in as well. What do I put in for time? A lot of you have been saying for me. So the idea here is you'll calculate the work and you'll calculate the power, but you shouldn't have to really calculate anything else, because we would have actually done this in class. So let me talk you through what we would have done in class, and then you can kind of decide what you want to put in the table, right? It's up to you. If you have the means to do some of these things at home, then you can go ahead and do it and measure stuff and time stuff, or you can just estimate. I really don't mind. So lifting a dumbbell that weighs 45 newtons, right? That in brackets there is telling you that dumbbell weighs 45 newtons. Okay, we lift it 10 times. So how much force is required to lift that 10 times? Well, if it's 45 newtons each time you lift it, right, and you do it 10 times, that's 450. So that's what I put in there, right? Second one, same idea. The brick is only 30 newtons and we only lifted 3 times. So I'm not going to do that for you, but it's the same idea as the first one, right? If you know how much it weighs and you know how many times you're doing it, that's the force altogether. Same for the third one, right? Lift 3 chairs, 10 newtons. So that's you're lifting 10 newtons 3 times. Okay, not going to insult your intelligence by doing that one. And then the last one, climb the flight of the steps at the front of Isaac Bear. I would love to say I went and measured them, but I'm not. I didn't. I estimated this, right? So that's how high I'm saying they are. Your weight in newtons. So this is because you're climbing the flight of steps. You are essentially lifting your own body weight up, right? So that's your mass in kilograms multiplied by 9.8. Now, if you have a scale, you can go and do that. If you don't, then you can estimate it. I really don't mind. Your weight in newtons should really be somewhere between, I don't know, 400 and upwards of just over 1,000, maybe, right? Depending on how much your mass is. But you're multiplying. For example, my weight would be about 80 kilograms times 9.8. That's just under 800 kilograms, right? So you get your numbers for force, right, in newtons, and then you need to know how far you're lifting each time. Well, that's, again, we would have measured this in class, right? I'm telling you the table's 0.92 meters high. I don't know that. Again, I estimated. Probably not. It's probably actually less than the one below it, but who cares? That's the number I've given you. These ones, this is the distance you lift something. It depends what kind of lift you're doing. It depends how tall you are. I don't really care what you choose to do, right? You can do, I don't know, bicep curl with a dumbbell, which means you'd be lifting it to about your chest height, right? But then, even then, you might decide that one of the times you lift it further. That's up to you to decide. But you combine that distance, right? So if you lifted it 10 times, then each time you do that, you are doing that same distance again. So again, let me do this first one. So let's say I lift this to my chest height, which is probably about, I don't know, 1.5 meters. So I do 1.5 times 10, which would be 15 meters. So altogether, I've lifted it 15 meters. Okay, now you could do it individually. You could do, so if we remember our work done equation, which is what we're going to calculate in this column here, is force times distance. Right, so I could do the work for each individual lift and then multiply it by 10. So I could do 450 times 1.5 and times that by 10. or I can do the distances all together. Now, the best practice would be to do each lift individually, right? So to do 1.5 times 450 and then add them all together, add the 10 different lifts together, or multiply by 10, because they should be the same each time. But if you know it's the same each time, then there's no reason why you can't combine the distance. If we weren't lifting the same distance each time, then you definitely have to do them separately and add them together. But in this case, you can, for these, they're all repetitive motions. So you can just kind of combine the distance for each one. Okay, then moving forward through this, we would then calculate our work as I just did. Whoops, I managed to erase everything, I just see. You calculate your work using force times distance, and then let me just put this top one in again, just so I've got it for reference. Whoa. Okay, and then I have my distance as combined 15 meters. I get my work, what is that? So 450 times 15. $6,750. Well, I don't know if I'm going to be able to fit that in there. 6,750. That looks like 80, but it's not. It's 50. Okay. Time. Now, again, this is completely up to you. We would have done this in class. We would have recorded it. Time to lift it 10 times. So I don't know what. About 2 seconds each one. So about 20 seconds maybe. That seems pretty quick to me. I don't really know. Not like I see the inside of a gym very often. And then you calculate your power from that, which is your work done divided by time. So I do 6,750 divided by 20, and that'll give me my power. And you do that for the rest of them. Times are up to you. Distances, you decide these top two based on your height and how much you lift it. Your weight in newtons for this one down here. And then these two you calculate the same way as I did this first one. And it's as simple as that. Hope that helps.